Page 92. A satellite dish is angled at 30 degrees to the ground. If the dish is 5 meters above the ground, what is the distance between the dish and the point where the signal is received on the ground? So we're looking for that distance. So I'm going to call that D for distance. Opposite is 5 and theta is 30. We know O and H, or want to know O and H, so this is a sine problem. Sine of 30 equals opposite over hypotenuse. Multiply both sides by D. So 5 over sine of 30 is going to equal that distance. And I need to give you a rounding rule. Let me find it. Page 92. Let's round to the nearest whole number. Again, this is just an arbitrary rule, so we all will have the same answer. We know if we're on the right track. So it is about 9 meters. A ski slope has an angle of 30 degrees. So here's the slope. If a skier is 100 meters down the slope, how far up the slope is the skier in vertical height? So we want to know this location. I'm going to call that vertical height. I'm leery of the letter H because that's easily confused with hypotenuse, so we'll use vertical. And we know hypotenuse is 100. We want to know the opposite. I'm calling that V. And we know theta is 30. So we're looking at sine. Sine of 30 is opposite over hypotenuse. So we'll multiply both sides by 100 and cancel. So that vertical height is approximately 100 times the sine of 30. And that's 50 if you round it to the whole. 50 meters. For this problem, I wish I had done it a little bit differently, so let me do it here. This problem's a little bit different to understand. Some people have absolutely no trouble at all. I'm going to take SOHCAHTOA out here just for this one. And I'm going to extend this picture for you. Let me read it before I just go crazy. The roof of a house has a 20-degree slope. So we know our good friend theta. But here's the catch. You have to realize that this is the roof. The picture I gave you is only half of the roof. In other words, I'm only showing you this much of the roof. And that doesn't matter with respect to theta, but it matters with respect to the 15. If the house is 15 meters wide, so it's 7.5 meters on this side and 7.5 meters on this side. That absolutely matters. The whole thing is 15. So the half that I'm showing you is only 7.5 meters wide. How high is the peak of the roof? So we're looking for this distance, which would really be this distance. The height of this segment is what we're looking for. So if theta is 20, We know adjacent is 7.5. The height is the opposite, so I'll call that little h. So we're doing tangent. The tangent of 20 is going to equal the opposite over 7.5. So the height of that peak is going to be approximately 3 meters. Be careful with that one. All right, last one on this page, we are surveying a building. A surveyor is 150 meters away from a building. So that's going to be on the ground. If the angle of elevation to the top of the building is 25 degrees, how tall is the building? So we don't care about hypotenuse. We want to know B, and we do know adjacent is 150 meters. So we're dealing with O and A, that's TOA. The tangent of 25 is opposite over adjacent. So we'll multiply both sides by 150. So the building is approximately 150 times the tangent of 25, about 70 meters tall. And that is reasonable for a building.